Lesson 3-5, solving equations with a variable on both sides. In this lesson, you learn to solve equations with a variable on both sides and to solve equations containing grouping symbols. Let's take a look at this real-world application in track and field. In the 1928 Olympics, the winner of the men's 800-meter run, Douglas Lowe of Great Britain, won the race in 1 minute 51.8 seconds, or 111.8 seconds. In that same year, the winner of the women's 800-meter run, Lena Radke of Germany, won the race in 2 minutes 16.8 seconds, or 136.8 seconds. Over the next 64 years, the men's winning times decreased an average of 0.127 per second of a second per year, and the women's winning times decreased an average of 0.332 of a second per year. Suppose the times continue to decrease at these rates. When will the men and the women have the same winning times in the 800-meter run? Okay, and let's see how we can solve this problem. Let's first find out what we know. So we know that after X years, the men's winning times can be represented by 111.8 minus 0.1227 X. Okay, so that would be the men's winning times. And after X years also, the women's winning times can be represented by 136.8 minus 0.332. Remember, 0.127 is a decrease, 0.332 is the decrease for women's, 0.127 the decrease for and time for the men's. Okay, and let's make an equation out of this. We now have what we know that if we equate these two, okay, when these expressions are equal, their times would be the same. So that's what we would do. We get 111.8 minus 0.127x equals 136.8 minus 0.332x. Okay, so many equations such as this one, okay, contain variables on each side. To solve these types of equations, first use the addition or subtraction property of equality to write an equivalent equation that has all the variables on one side, then solve the equation. Okay, and let's follow method 1. 111, okay, 0.8 minus 0.127x equals 136.8 minus 0.332x. Okay, we just copy down the problem, and in this case we are utilizing a calculator. Okay, so we want to have all the variables on one side of the equation. That means we need to get rid of one of the variables on the other side. So in this case, we add 0.332x to both sides of the equation. Why? Because by adding 0.332x to both sides, we get rid of the x on the right side of the equation, because that will be equal to 0. So if you do that, you now have 111.8 plus 0.205x. That is the difference between negative 0.127x plus 0.332x. Okay? And then we simply bring down 136.8. Now the variable is on the left side only, and now we can solve for the variable. Okay? Using what we know in solving for the variable x, we follow a two-step, okay, two-step plan to be able to solve this equation, meaning we subtract 111.8 to both sides of the equation, end up with 0.205 equals 25, because the difference of these two numbers will be equal to 25. And then to be able to solve for x, since 0.205x is multiplication, we simply divide both sides by 0.205. We end up with x is approximately 122. Okay, so what do we know? At these rates, okay, the men's and the women's winning times will be equal about 122 years after 1928, or in the year 2050. In the year 2050, okay, expect that the winning times for men's and women's for the 800 meter run will be the same. Okay, So let's take a look at method 2 and see how method 2 works. Method 2, since two of the decimals involve thousands, another way to solve the equation would be to multiply each side by 1,000 to clear the decimals. So if you're not comfortable dealing with decimals, find out the greatest place value in the decimal system. In this case, it's the thousands place, okay, or the least place value in the decimals place, and that's the thousands place. Okay, and then if it's a thousands place, you simply multiply both sides by 1,000. If you multiply both sides by 1,000, if you notice, okay, all the decimals will disappear, okay, but you'll end up with bigger numbers. You have 111,800 minus 127x equals 136,800 minus 332x. And the same thing applies. You get rid of one of your variables on one side by adding 332 to both sides, 332 to x to both sides, and if you add 332x to both sides, you end up with 205x, and then we simply get rid of 111,800 by subtracting it to both sides of the equation, and finally dividing both sides by 205, we end up with x is approximately 122. And that's how method 2 works if you're not comfortable dealing with decimals. Okay, let's take a look at example number 1 and see how this works. You want to solve 3/8, okay? Minus 1/4 x equals 1/2 x minus 3/4. Again, we have variables on both sides, the left and the right. The first thing we need to do, if you're not comfortable again dealing with fractions, then we multiply both sides by its least common denominator. But before we do that, let's copy the problem first. Okay, so the least common denominator of 8, 4, 2, and 4 is 8. So we multiply both sides by 8. Okay, using the distributive property, you end up with 3. Okay, 3/8 times 8 minus 8 times 1/4 x. 8 times 1/2 x minus 8 times 3/4 x. Okay, simplify that. You now have 3 minus 2x equals 4x minus 6. Okay, now we still have two variables, okay, on both sides, so we want to get rid of one of them. We simply add 2x to both sides. If I add 2x to both sides, this 2x will go away and this becomes 6x. Now we have x on the right side, and this is a simple two-step equation. So we add 6 to both sides, we end up with 6x equals 9, and then we divide both sides by 6 to and then you get the value of x, which is 3/2. So the solution is 3/2. Okay, the value of x will be 3/2. Let's take a look at the next example. When solving equations that contain grouping symbols, first use the distributive property to remove the grouping symbols. Okay, one angle of a triangle measures 10 degrees more than the second. The measure of the third angle is twice the sum, okay, of the first two angles. Find the measure of each angle. Okay, well, if you are a visual learner, you need to create a drawing out of this. Make a drawing, and let's do and your drawing would look like something like this. Okay, so one angle of a triangle is 10 more than the second. That's what you got there. Okay, the measure of the third angle is twice the sum of the first two angles. That's the first angle. This is the second angle multiplied by 2. And then that's how your let statement came about. So let y be the measure, okay, of the first angle, and let y plus 10 be the measure, okay. Oh my goodness, let me click all of these. Okay, so let y be the measure of the one angle, let y plus 10 the measure of the other angle right here, and let 2 times the bracket y plus quantity y plus 10 close bracket equal the measure of the third angle. Recall that in a triangle, the sum of the measures will be equal to 180 of all the angles. Okay, so knowing all of that, we create our equation adding all three angles to get a sum of 180. So y plus y plus 10 plus 2 times y, 2 times bracket y plus the quantity y plus 10, close bracket, equals 180. Okay, let's simplify this expression before we try to solve for y. Okay, again, if you recall, an expression is in simplest form if there are no parentheses and there are no like terms. So in this case, we have a lot of parentheses and we have a lot of like terms. So this is nowhere close to being simplified. Okay, let's take that. Let's take the next step. Okay, so now we have 2y plus 10, which is we simply added y plus 10 plus 2y plus 10. We added y plus y on the inside of the bracket. It ends up with 2y plus 10. Okay. Using the distributive property even further, you now have 2y plus 10. We simply copy 2y plus 10. 2 times 2y is 4y. 2 times 10 equals 20, equals 180. So we don't have now parentheses, but we still have like terms. So we need to add 2y. Okay, we need to add the 2y and the 4y. So once we add the 2y and the 4y, we end up with 6y. Okay, 6y plus 150. Sorry, 6y plus 30 equals 180. And then we subtract. Okay, now that we have simplified that expression, we can now solve for y. Again, you cannot solve for y until the expression has been simplified. So we've simplified that expression. Now we can solve for y. We subtract 30 to both sides. Okay, which brings us to 6y equals 150, and divide both sides by y, end up with y equals 25. Okay, so the measure of one angle would be 25, the measure of the other angle would be 25 plus 10, or 35, and the measure of the third angle would be 2 times 25 plus 35, or 120. Now, to be able to check your result, simply look at this. If you add 25 plus 35 plus 120, it will equal 180. Our answer checks out. Okay, let's take a look at example 3. Example 3, some equations with a variable on both sides may have no solution. Okay, that solution, that is, no value of the variable, will result in a true equation. Okay, let's take a look at example number 3 and see how we come up with a solution or no solution. 5n plus 4 equals 7 times the quantities n plus 1 minus 2n. Again, we have parentheses here. That means we need to get rid of the parentheses to be able to simplify that. And in order to do that, we need to use the distributive property. If you use the distributive property, you'll end up with hold on, let's copy the problem first. There you go. And then after copying the problem, use the distributive property. You have 7n plus 7 minus 2n. Okay, and from there we add like terms. Again, we cannot solve for the variable until we've simplified both sides. Okay, you can, but it'll take you longer. Okay, and the propensity for making mistakes will be higher. So let's simplify this expression first. We add like term 7n minus 2n, end up with 5n, 7, 5n plus 4. Now, no parentheses, no like terms on both expressions. We can now solve for n. Okay, and to be able to solve for n, remember, variable on both sides, we subtract, or we want to get rid of one of the variables, and we subtract 5n to both sides. And if you notice, if you subtract 5n to both sides, you end up with 4 equals 7. And we all know that 4 will never be equal to 7, and that is a false statement. So this particular equation has no solution. Okay, so this equation has no solution, and you end up with that kind, with an inequality, or sorry, with an equation that is not a true sentence. Okay, let's take a look at this example. 7 plus 2 times the quantity 2x plus 1 equals 2x plus 9. Again, we don't want to solve for x first until we've simplified both sides of our equation. Let's copy the problem again. 7 plus 2 times the quantity x plus 1 equals 2x plus 9. Using the distributive property, we distribute 2 to x, distribute 2 to 1, end up with 7 times 2x plus 2 plus 2x plus 9. We still have like terms, we can still add 2 plus 7. So this becomes 2x plus 9 equals 2x plus 9. Okay? And if you notice, this is a clear example of the reflexive property of equality, which simply means this. Since the expression on each side of the equation are the same, this equation is an identity. The statement 7 plus the quantity 2 times x plus 1 equals 2x plus 9 is true for all values of x. So in this case, we will have a solution that is all real numbers. Okay, so notice the difference between example 3 and example 4. Example 3 will have a solution of will have no solution, and example 4 will have all real numbers as its solution. And that is the end of our lesson on Google Forms or MyBigCampus. Type a summary of what you've learned by responding to the objectives of the lesson, and type a question you may want to ask in class about this lesson. Thank you.